Okay, so let's start this. Okay, page. Okay, so today we're gonna go over this exam from 2 years ago. So yeah, I'm just recording by myself. It's gonna be weird, but okay. So if you guys have any question, please email me, and I can try to make things a little bit clearer. Okay. Okay. So first, let's start with first question. So how we're gonna do this? So when you see this on the exam, first, please. Mm, okay. Okay. So first, in the exam, make sure when you see an equation, please mark it. Okay. So the first, this is production function. And return on capital, this is rent, which is cost of capital. Okay. And then this is cost for labor. Okay. So we have this two equation. Now we can start the question. So here we have a production function, Q equals to K times labor squared. Okay. So this is capital. This is labor. Okay. So capital is also machinery. That's it. Okay. So we also have cost of capital. In this case is $5. Cost of labor, $15. Okay. So A. So we need to find isoquant. Okay. So if we're drawing graph, drawing isoquant, we need to first start with a table. So let's draw a table. So we know that isoquant has three components. So one is quantity, one is labor, one is capital. Okay. So here, this. So in this case, it's given that quantity equals to 12. So Q equals to 12. So when we're drawing the isoquant, we want to keep the quantity the same and just change in different combination of labor and capital. Okay. So let's draw 4 point. I'm gonna draw 5. Okay. So we have this production function right here. So 12 equals to k times L squared. So first, let's think about this labor. As an x. Okay. So x times k equals 12. So there's a few of them. Let me just erase this. So we have x. Oh, this is labor square. And we know this is labor. And this is capital. Okay. I think this might be easier for you guys to make sure things are right. So what times what equals 12? So 2, 12, 6. 2 times 6, 12. 1 times 12, 12 times 1. 3 times 4, 4 times 3, right? So we know that we get over all our x and k. So now we're trying to find L, okay? So x equals to L squared. If x equals to 2, L squared, so L equals to 2 square root, okay? So we just square root everything on x. Square root of 2, square root of 1, square root of 12, square root of 3, square root of 4, which is equals to 2. Okay, so square root of 1 equals 1. Now we have all that. Which is this. Now we can draw an isochron. Okay, so make sure on an exam, try to bring a graphing paper. Makes life a little bit easier. Okay, so in this case, I'm gonna put labor on top and then capital on bottom. Because I did this question a few times, that whenever I put capital on top, it always look weird. But anyway, ideally, either way should work. Okay. So let's just graph this graph. So our maximum k is 12. So let's maybe do 1 to 20. To 20, let's do 2. 2, 4, 6. 15, 16, 4. And then L, we can do 1. Let's not do 1. Let's do a little bit bigger. 1, 2, 3, 4, 5. So as long as it's in scale, whatever, it should be fine. Okay. Shrink this a little so you can see the whole thing. And let's just graph it. So first dot, it's 6 and square root of 2. So 6 for capital and square root of 2. So what does square root of 2 equals to? Square root of 2 is between 1 and 2. Okay. So square root of 4 equals to 2. Square root of 1 equals to 1. So we know that square root of 2 must lie in between 1 and 2. So lies between 1 and 2. So it's somewhere, I would say somewhere here. All right. In the exam, use calculator and it should work. Okay. So 1, 12. 12 capital, 1 labor. my mistake. Between 1 and 2, right? And then square root of 12 and 1. So we have k equals to 1. And then square root of 12. Square root of 12 is between square root of 16 and square root of 9. So this is 3, this is 4, so this is 3 point something. Okay, so we have 1 as capital. And then 3 point something. I would say maybe it's like slightly here. I don't know. I'm just like estimating. The exam, don't try to estimate, try to find the real number. Yep. And 1 square root of 12, and then 3 and 4, so 4 right here. Square root of 3 is between square root of 1 and square root of 4. Square root of 3, probably somewhere here. Could be my estimate, it's too big in the previous one. Something like this. And then that's why it's 2 and 3. 2 and 3. Hmm. 3 is capital. 4 is capital. Oh. 2 and 3. Over here. Over here. Connect the line. Okay. Oh, and we have 1 labor to 12. Yep, we do have that. Okay. So let's look at the question. We finish Q equals to 12. Now let's do B. Two isocost line. Okay. 2 isocost line. Let's do 2 isocost line. B. Draw isocost. So what's isocost? Isocost is the cost of producing any output, right? So output Q equals to price of labor times quantity of labor plus price of capital and the number of capital. Okay. So in this case, quantity output, yeah, not exactly. It's the cost, right? So it's the total cost. So total cost, in this case, we have 45 equals to PL plus PK K. And then we have another function, it's 65. Oh, no, it's not 65, 60 equals to price of labor times quantity of labor plus price of capital times number of capital, okay? So in this case, so with isocost line, we're always trying to find 2 points, right? So 1 point is 1 K equals to 0, right? So when K is 0, this thing we ignore, okay? Then we get this. We know price of labor is 15. So 45 equals to 15 comes out. And L equals to 3. So K equals 0, L equals 3. Well, when another point is when L equals 0. So when L equals 0, L equals 0, we ignore that part. Okay, so we have 45 equals to price of K. Price of K is 5. 5, K equals to 9. So we get 2 points. 1 point is 9, 0. This is 0, 3. Okay, 9, 0. This line is okay. 0, 3. Right here. Like this too. Make sure it's straight. Okay. Okay. And then we have another line, just 60. The 60, we're doing the same thing. In this case, is K equals to 0. So 60 equals to, the price didn't change, so it's still 15L. And L equals to 4. And then we do another case for when L equals to 0. When L equals to 0, we have 60 equals to 5K. K equals to 1, 2, 12. So we got 2 points. This is 0, 4. This is 12, 0. Okay, so I'm gonna draw on green. 12, 0. 12 is right here. And 0, 4 right here. That's curvy. Okay. Now we have a 2 line. Okay. So that's it for B. That's all B was asking for. So how to just conceptualize this is that, okay, now you have $45, $45. If you put everything into labor, how much labor can you afford? If you put everything into capital, how much capital could you afford? So we find this 2 endpoint, and then everything in between is a combination of labor and capital that we can afford. Okay, so that's it for B. Let's do C. C, what makes input well for truths? Why? Explain the economic intuition. So this place, what would Ford do? Okay, so in my graph, it's clearly this point. Yep. So that point is 3, 2. Okay. So Ford will choose 4 units, 3 units of capital and 2 units of labor. Okay. So this question is asking about the economic intuition. So we know that this production function right here with green is that any combination of labor and capital that can at least produce 12 units. Okay. So we know that this black line is any combination of labor and capital we can afford. So this tangency line is when the combination of labor and capital that we can afford is the same as any combination of labor and capital that can produce 12 units of output. Okay? So look at this green line. So we have this green isocost curve, right? So why don't we want this 2 points? This point A and point B. We don't want that point because we're not minimizing cost. All right. So because we can potentially have another isocost line right here with a tangency when we can produce more quantity of output greater than 12. So this is Q equals to 12, right? So it's not efficient. And we would never try to pay more if we can pay less, right? So the tangency point is our best combination of labor and capital to produce 12 units of output with the lowest cost. Okay? That's it. Okay. Bond. D. So does production function exhibit increase, decrease, or constant return to scale? How mathematically and explain your result. So this case, there's a 3 case, right? So let me do first. Increase return. Scale. It means that Q of labor and capital equals to, let's just use our function for now. Not use our function, but so Q of L and K is a function of K and L. Okay, so if we increase everything double for capital and labor, what happened to quantity, right? So increase the return to scale is that if you double it, if you double everything in your input, it will give you more than double of your output. Okay, so let's look at our function. So in this function, it's actually increase return to scale. So Q equals to K L square. So if we increase everything in K and L, we will have 2K times 2L square equals to Q, right? So in this case, if you don't know how to create this, you can just plug in number, okay? So I'm gonna just plug in number. So I have 1. So 1 times 1 squared equals 1, right? So if I double it, it would be 2, 2, and 2 times 2 squared is 4, right? So 4 times 2, that's 8. So we double our input, but we 8 times our output. So this function would be increased return to scale. Let me just erase this so I don't confuse you. Okay, so I'm gonna give you a function that's constant return to scale. Okay, so I'll have Q equals to half K times 1/4 L. Okay, so this is 2 constant return to scale. This is not the most efficient way to test it, but it will work for every scenario. Okay, so just plug in the real number and then test it out. Okay, so we're gonna plug in 1, 1. So half times 1/4, that is 1/8. Okay, so what if we double of our input? What happened to our output? So it will be 2 times 1/4, that's half. 2 times half, that's 1. So this is half. Right? So we double. Our input. I did something wrong. This is That's true. That's true. Oh, interesting. So this is not a constant return to scale. Okay, my bad. This is still increased return to scale. Okay, let me give you function. Got it? Let's do this. Square root of L. And then square root of K. Okay, so Q equals to half 1 square root times 1/4 1 square root. We get half times 1/4 equals 1/8. So if we put 2, we double everything. So it's 2 1/2 times 1/4 square root of 2. So square root of 2 is 2. So 1/2 times 1/4 times 2 equals 2 cancel. So we got 1/4, 1/4. Okay. So we have this and this. So if we double everything, we double the output. Okay. So that's constant return to scale. It's testable. And yep. Sorry about a confusing example previously. Now we're gonna do something called decreased return to scale. Okay, so decreased return to scale would be something like this. Return to scale. Always not a good number. I'll just give it like this. Okay. So if we plug in number of 1, Q will equals to, so let me use calculator. Right back. One, a 1. The Q equals 1. Okay, what if you put 2? You get 1.148 times 1.148. Okay, so that will be Q equals to 1.3195. Okay, so we double our K and L, but our quantity actually increased by 1.3, not 2. So this would be an example of decreased return to scale. And here's our 3 example. We can still use the same method to test whether or not it's increase or decrease or constant return to scale. Okay, so now let's try to do E. Suppose K equals to 5 and NP, what's the marginal productivity of the third hour of labor? So what's marginal productivity of labor when L equals to 3? So what's the function of a marginal product labor? Marginal product labor is change in Q divided by change in 1 unit of L. Okay, so if you have learned calculus, it's fairly trivial. It's basically just production function Q equals to K times L squared. You just take the derivative with respect to L equals to L. Okay. So let's do this very old traditional way. But this change in Q of change in unit of L, we have to first find out what's our Q when K equals to 5 and L equals to 3. And then we need to find a new Q. So it is Q1, Q2, when K is keep constant and L is increased by 1 unit. Okay? So in this case, just draw this out. We'll have three, 9, 45. 16 times 5, 80. Okay. So our MPL equals to 80 minus 45 divided by 2 minus 1. So change in quantity of output will increase by 1 unit of labor. Okay? That's not 2 minus 1. That's 3 minus, no, 4 minus 3. Because we increase by 1 unit of labor. How much increase in output? It's 80 minus 45 is equals to labor 80 minus 45. 35. So your MPL equals 35. And that's it. If you're doing the derivative, so this session, only for the derivative, you take the derivative in respect to L, and you plug in L. dq dl equals to 2 times 3. dq dl equals to 6. So why such differences in marginal product of labor? I'm going to explain now. So this is labor, this is Q. So in this case, in order to explain it, let me just not. So I'm not gonna explain it in detail, but it's basically this. You have a point. So this point is when K equals 5, L equals 3. So when L equals 3. So, ooh, draw the wrong graph. Not bad. Actually look like this. Just draw a little bit more dramatic because it's Q equals to K times L squared, right? So L squared must be in here. So if it's square, it's an exponent function. So we're gonna find the slope. So MPL is, let's say, this is 3. And then this is 4. Okay. So when we're doing this method, we're actually finding slope with 4 and 3, right? We're finding this. This is changing Q, changing L, right? So that slope, it's gonna be very different from this slope. Can you see? I'll put it red. So when you're taking derivative, when L equals to 3, this is at this moment, what is my slope? So the slope, 6. And then when we're doing the method with the change, because we're using 4 and 3 and take an estimate of a middle, that will be just between the slope. So we're actually taking a point somewhat right here. Right? The slope of right here. This slope is probably equal to this slope. Okay? Drawing green. And black is better. Okay? I don't know if you can see it. So this is 2 different marginal product of labor, which is fine, because either one will be correct on the exam. So if I were you, I would use this method. Okay? You will never get it wrong. Okay? And the derivative is more for calculus. And if you haven't learned anything regarding to calculus, you should not do it. Okay? So that's marginal productivity. So what does this marginal productivity of labor mean? I think I just I briefly explained it. It's how much product you're gonna get when you increase 1 unit of labor and everything else constant. Right? So keep capital constant and trying to find additional units of labor that has effects on your quantity. If you want to find MPK, which is marginal product of capital, you keep labor constant. Okay. Next, going to cost. I'm spending way too long, but I hope this helped. With this one, it's actually plus. minus. So we'll have C Q equals to 9 plus Q squared divided by 4. So whenever you see this, so yep, create a table, right? Okay, so I'm just not gonna do it here. I'm gonna do it here. So let's find the function for ATC, AFC, AVC, and MC, right? So this, putting the definitive black. So this is total cost function. This is 9. When quantity equals to 0, you got $9 cost. So the 9 is fixed cost. And anything else respect to Q, that's variable cost. Fixed cost. Okay. Now we have average total cost, average fixed cost, average variable cost, and marginal cost. So we need to find the equation for those. So average total cost would be cost of Q divided by Q. In this case, 9 plus Q plus Q squared divided by 4 divided by Q. Yeah. I have a problem with like writing my 9 and Q. Okay. So in this case would be equals to 9 divided by Q plus Q divided by Q is 1 plus Q squared divided by 4Q. Q cancel out. So this thing will equals to Q divided by 4. The average total cost function is equals to 1 plus 9 divided by Q plus Q divided by 4. That's it. The average fixed cost would be 9. 9 divided by Q. Average fixed cost. Okay. Let me organize it. Average variable cost. I have a variable cost defined right here. So it's Q plus Q squared divided by 4 divided by Q. It's equals to variable cost divided by Q. So average fixed cost is fixed cost divided by Q. Okay. So anything with average is always like divided by Q. Okay. Okay. So in this case, our average variable cost would be equals to 1 plus Q divided by 4. Then now we have to find marginal cost. So how do we find marginal cost function? Marginal cost function is change in total cost over change in right? So usually the change in quantity is 1 unit. Right. That's it. So next, I have to do the table. And we have all the functions, so we just drag it down. I can't. Okay. So let me just do it. So average fixed cost is 9 divided by Q. Average total cost is 9 divided by Q plus, this is a plus 1 plus Q divided by 4. Average variable cost is 1 plus Q divided by 4. Here. Marginal cost is change in total cost by change in Q. Okay, when we have a 0, what's our total cost? 0, 0, it's 9. Okay. Now, what if we have 1? So 1 is 9 plus 1 plus 1 divided by 4. 10.25. Average total cost is total cost divided by quantity. Average fixed cost, 9 divided by 1 equals 9. Average variable cost is 1 plus 1 divided by 4, 1.25. And we have a change in total cost and change in Q. So previously we have 9, and now we have 10.5. So 10.5, no, 10.25 minus 9 goes to 1.25. So our marginal cost is 1.25. What do we have? Two quantities. Two quantity, 9 plus 2 plus 4 divided by 4 goes to 12. So average total cost is 12 divided by 2, 6. Average fixed cost, 9 divided by 2, 4.5. Average variable cost, 1.5. Marginal cost is 12 minus 7.25, 1.75. This is 12 plus 1 point, no, 2.25, 14.25. 14.25 divided by 3. So, equals to 6, 4. Average fixed cost is 9 divided by 3, 3. Average variable cost is 1 plus 3 divided by 4, 1.75. Marginal cost is 14.25 minus 12, 2.25, 9 plus 17. Average total cost is 17 divided by 4. 4.441. The average fixed cost is 9 divided by 3, not 9 divided by 4, which equals to 2.25. Average variable cost 1 plus 4 divided by 4 equals 2. Marginal cost is 17 minus 14.25 equals to 2.75. Okay, so we have this table. Now we do a graph. Okay, so now I'm going to draw a graph. So this is money. This is quantity. Price and quantity. Okay, so we have really tight area for quantity. So I'm gonna make it a little bit bigger. This is 1. This is 2. This is 3. And then this is 4. So as long as you're in scale, you're fine. 2, 4. And then money is from 17. I guess I have to go up. Okay. So we'll have 2, 4, 6, 12, 14, 15, 16. I think 16 should be enough. 17, 5. I'll just put it here. 17. Okay. So let's do first equation. When quantity is 0. Well, fixed cost is 9. Black line is fixed cost. Okay. So I'm gonna do average fixed cost first. 9, 1 units is 9. 0 units, it's not. And then second unit is 4.5. 4.5. 3 units, 3. 4 units, 2.25. Fixed cost. Then I'm going to change the color to red. Red is average total cost. So first units of average total cost, it's 10.25. 6. 6. Wait, something is wrong with 3. Divided by 3, right? That's 9 divided by 4, so divided by 3. That's 3 over 4. That's 4.17 to 4.75. My bad. We can check with calculator. Then use calculator, and you should 14.25 divided by 3. Yep, 4.75. So we'll have 9 for 4.75. And then fourth, that's the line. Okay. Now we're gonna use bright blue for, my bad, average fixed cost, average total cost. And then we're gonna have bright blue for average variable cost. So for 1 unit, we have 1.25. 1.5, 1.75, and 2. Okay, slightly underneath the average fixed cost. Yeah, a little bit not too accurate, but it's accurate enough. And then we have marginal cost. Marginal cost, I'm going to use green, 2.5. 1.75, 2.25, 2.75. Okay. So blue is average variable cost. Green is average marginal cost. Okay. So we have the graph right here. I will give you full credit. Okay. Next, question 3. Question 3 is, it's very, how do I say? It really depends on this formula, right? And it will be given on exam, so you shouldn't be worried about it. And mostly it's just apply this equation and understand the intuition. Okay. So we have 40 firms, so n equals 40. And we have market price elasticity for supply is estimated to equals to 6. So market supply 6, market demand equals to -2. Okay. So we're trying to find individual firms demand, right? So it's all given. Now we just plug it in. So EI goes to 40 times 32 minus 39 times 6. So EI goes to 80 minus 9 goes to negative 314. Okay. So this is the residual demand. Oh God. Residual demand. And interpret this number. So we know that elasticity is greater than 1. It's very elastic. Not like very, I would say elastic. And if elasticity is equals to 1, it's unit elastic. And then if elasticity is less than 1, it's inelastic. So we have an elasticity of negative 314. What does the negative 314 looks like? It looks like so. Hmm. So if it's greater than 1, means looks like this. This is 0 units. This is the price. This is quant. And this unit is, let's see, 300. Okay. All right. That's a bad metaphor. Okay, just forget about this. But it will look very vertical. No, very horizontal. Something like this. It's your thing now. Okay. So when you change your price by 1 unit, you're gonna lose all your business. Quantity, price. Okay. So this is very elastic and it's super competitive when it's 300 something, right? So we learn about the perfect competitive market. Perfect competitive market, everybody, is a price taker. The supply supply, price, and quantity. So whatever you produce, you're gonna sell at demand. If you try, oh, my bad. My bad. So you're trying to sell here, like if you try to increase by 1, no, I was right. Okay, forget about this. I'm like a little bit too tired. Um, so you're trying to like increase by one units, or no, 1 unit of price. You lose all your demand. It's like you're selling eggs in the market, right? If you're trying to increase your egg by $1, nobody's gonna buy your egg because the next shelf it's gonna be $1 less than you. Okay, so perfect competitive market. In this case, change in 1 unit, 1%. Hedge on price. Let's say decrease 1% on price. It's gonna increase your quantity demand by 3.1400%. That's not true. I was thinking about 100. Okay, so if you increase 1% on price, your quantity demand decrease by 314%. So that's the intuition. Okay, so let's jump to last question. Just do it here. Suppose the market is perfectly competitive. Perfectly competitive. This is very important. The previous question, I was like listing when perfectly competitive, our demand is flat. So price goes to $8. And cost function is 25 plus 4q plus 1/2, no 1/4 q squared. And then marginal cost equals to 4 plus 1/2 q. So when you find the profit maximizing quantity for Hula High, we know that if a firm wants to profit maximization, max, marginal cost must equals to marginal revenue equals to price. So we know that P equals 8. So we just set P equals 8 equals to MC, A equals to 4 plus 1/2 Q. And Q equals to -4 4. So 1/2 times 2, say. So quantity is 8. Put it here. Do we need to make a graph? Okay, a graph would be very helpful. Okay. So let's do marginal cost. So we know that market price is 8. So in perfect competitive market, that means anything above $8, it's not gonna sell. So the demand only at $8, right? And in this case, we have equilibrium and we find that quantity equals to 8. So why don't we sell 9? 9 units of quantity. In this case, we don't want to sell 9 units of quantity because we're losing money here, right? So 9 times times 1/2 plus 4 equals to this price 8.5. So for 9 units, it actually costs us this additional units increase costs us more. Okay, so this costs us more, therefore we don't sell at this unit. So we're losing money by this increasing amount. Okay, so why don't we sell it at, like, for say 7? Because in unit 7, price is less than our cost. Well, no, our price is higher than our cost. Therefore, if we don't sell it one more unit, we're losing this much profit. Right? So we have to sell it when MC equals P. So let's do what's Hula highest profit. So what's profit function? Profit function is pi equals to revenue plus total cost. Minus. In this case, what's our revenue? This. What is our revenue? Is revenue equals to price times quantity, which is 8 times 8. 64. R equals to 64. That's our total cost. Total cost is our total cost function of 25 plus 4Q plus 1/2 Q square. $25 plus 32 plus half of square root of 8. That's square root of 8. So 64. Right? 8 times 8, 64. 5 plus 32 plus 32. 64 plus 25 equals to 89. So our profit is 64 minus 89. We're losing $25. So our profit equals to negative 25. So we know that Hula High is losing money. Should they shut down? No, they should not. Because they're still making a positive when it comes to covering the fixed cost, right? So how much money are they making? Is 8 times 8 minus. So we know that marginal cost must equals to price, right? So when in the perfect competitive market, we're making 0, right? We're making 0 economic profit. But we're still making profit that covers our fixed costs or cover all of our variable costs. So therefore, we should not shut down. But when variable cost is equals to price, that's our shutdown point, right? So how can we calculate variable cost? So variable cost, I'm just gonna write here, cost, average variable cost. Average variable cost is 4Q plus 1/4 Q squared divided by Q equals to 4 plus 1/4 Q. Okay. If our average variable cost is equals to price, that's our shutdown point. So what would that be? So 8 equals 2, 4 minus 4 Q 4 4 times 4 Q equals to 16. So there's something wrong. Hmm. Hmm. Oh, oh, okay, okay, okay. I see where I did wrong. So let's see. Let's find average variable cost when unit is 8. So when unit is 8, it's 4 plus 1/4, 8. So average variable cost would be 8 divided by 4 is 2, so it's 6. So average variable cost of quantity equals to A is $6. So when this is our equilibrium, our average variable cost is actually lower right here. That means at this price, $8, we still have $2 of gain, excluding fixed costs. So this actually $2, you can use it to pay fixed costs, right? So we should not shut down. The only time we shut down is when price is lower than average fixed cost. Oh no, average variable cost. This is our shutdown point. Okay, I'm gonna explain this using an example, which is that imagine yourself having a sandwich shop, right? You need to put labor, you need to put material costs, you need to pay rent to in order to sustain your sandwich shop, right? So let's say right now the market price for the sandwich is $8. And the cost for you to making that sandwich is $6. Are you gonna sell it? Of course, right? You make extra $2. Okay, you can use that $2 to pay your rent. So you should not shut down. When do you shut down? It's when you're making a sandwich, but by making that sandwich, you're losing money. So for example, that right now market price is at $8 and your average variable cost is 10. It costs you $10 to make a sandwich because increased price in the patty or increased price in the worker that makes the sandwich, it costs you $10. So you're losing $2 for making every sandwich. Of course, you're not gonna make that sandwich. You said, screw it, I'm not gonna sell you this sandwich, right? So that's the shutdown point. Okay. All right. Let's look at the very last question. Ooh, yeah. So let's see. Okay. So if the firm in the hula industry are identical, exactly similar to hula high, what is the quantity supply by the market when the market price is 8? Okay. So now we have 40 firms. 40 firms. Where's my question? So now we have 40, right? So this is one firm. So we have 40 firm now. Exactly at $8. But what's the quantity? Is what I was asking. So if we have one firm that is selling 8 units for $8. If everyone's supply and demand are the same, how much would I sell? So basically just A times 40. 320. So quantity is 320. I can't imagine. I don't know if there's any way to get this question wrong. But if they're exactly the same, that means their cost is the same. And at price of 8, the market is gonna eat it up no matter how many quantity, right? So if everything is the same for every firm, so there's 40 firms, and then sell it, each firm selling for a unit. Yeah. That's it. Okay. So if you have any question, email me. And I'll see you guys in Tuesday if there's any question. Good luck on the exam.